Hello everybody, welcome to the Python course. In the previous part, we have covered module 11, that is Introduction to Numpy. We have also seen how we can create our arrays using the Numpy library. We have also covered the part in which we can perform various operations on the arrays, that is Numpy arrays, and we could manipulate them. Right? In this part of the lecture, we will cover the module 12, that is Introduction to our Pandas library. Here we will see how we can create our series and data frames in Pandas library, how we can perform the arithmetic operations on series and data frames, how we can export or import the data which is being contained in our CSV file or text file, that we can take it in the form of our data frames and then perform various operations. Right. So basically this pandas library is used to clean our data. Right. We can perform various data operations on our data set. We can perform the exploratory data analysis, right? And then we could apply the machine learning techniques to come with a prediction. Right. So let's start. So I have already opened up my Anaconda navigator, right, and already opened up my Jupyter. So I'll go to documents, GitHub projects, Python trainings, and Trunic, and there is already a module named Pandas, right, which have already been created, right? So okay. So in this lecture, we will cover about the series object, and we will see how a Python dictionary could be converted into a series object. Then we'll see further how a Numpy array could be converted into a series object. Right? So we will also see what are data frames, index objects, how we can reindex objects, and perform various operations on this series and our data frame objects. So let's start. Series. So series is a one-dimensional array-like object containing an array of data. So this data could be of list type, could be of Numpy data type also, right? The only difference between our series and our Numpy array, right, is that in the series we could have our index, right? So it also consists of an associated array of data labels, which is known as its index, right? Okay, so here this is our one-dimensional array, or you can see that list, right? We have converted into a series, right? And after conversion of series, this object has resulted us in giving us the index also, right? So let's see how we can do it. First of all, we need to import our pandas as PD, right? Earlier we have tried working with your Numpy, so it is better we also import that Numpy library. We will be also needing this Numpy array, right? So that's why I've imported both the libraries, right? So let's name this as series 1 and Numpy dot PD dot series, right? And in the series, let's take a list. Now you can see that this series, right, this list has been converted into your series object, right? If I try to type the data type of the series object, it says panda.core.series and series, right? This means this object is of series object, so it has emerged from this class, right? Panda.core.series dot series, right? Okay. So this, we know that this Python list could be converted into a series object by giving us the pd.series command, and we could easily convert it using our Python list, right? Okay. So in the previous example which I have told you, that index was only your default index ranging from 0 to length, right? Length minus 1, you can say that, right? But if you want to have our user defined index, then you can specify the attribute in our series object, right? So basically we are trying to create a series object, and in the parentheses we are giving the parameters. So this is the object, or this is the list we are trying to convert into a series object, and we are also specifying the index. If we don't specify the index, then by default the index will range from 0 to the length minus 1, and if we try to specify that, then its index has been converted into your user defined index, right? So here you can see that the index is your user defined index which you have given, right? So let's try to convert it series to equal to pd dot series, and in this part let's say I take the numbers and index equal to, let's say I'll take it 1, 2, then 3, 4 and 5, right? So here you can see that your index is 1 2 3 4 5, and here the numbers are 1 2 3 4 5, that is the integer values. But in the previous example I have not specified any index, so the index was by default ranging from 0 to length minus 1, right? So this means if you are trying to convert your list into your series object, then you can give your index also, right? Okay. So we have seen how we can convert our Python list to the series object. Okay. The next part is we can also convert our Python dictionary to the series object. So here in this example you can see that this is a Python dictionary in which the index is India, Australia and Japan, and the values are cricket, tennis and boxing, right? So this can also be converted into your series object, where your index becomes the index of your dictionary and your values become the values of your dictionary, right? Okay. And now here, if I have in dictionary duplicate indexes, duplicate keys, here you can see that USA is your duplicate, right? So as per the definition of dictionary, we can say that we cannot have your duplicate keys in your dictionary, right? So if we want try to change it or try to have this kind of dictionary, so it will take only the last value, because the earlier values will be overwritten, right? So in the end we will only get USA as our key, and the value will be rugby, right? So if we trying to convert our series, convert the dictionary into a series object, and it will result us in giving us a single value, because we cannot have your multiple indexing or multiple keys in your dictionaries, right? Okay, so this is a problem in our dictionary. So I will also tell you how we can solve this problem, right? How we can solve this use case. First of all, let us try to convert or have convert our Python dictionary into a series object. Okay, so let me take another example, that is series 3, that is pd dot series, and here I'll take a dictionary, right? Okay, so I'll take okay, India is equal to, we'll say cricket, Japan equal to football, USA equal to rugby, right? And we'll take another, China equal to volleyball. Right, so now you can see that there are different countries and corresponding they are the games which are played in these countries, right? So this is perfectly fine. We have converted our series dictionary into a pandas series object, right? Now suppose I take another example in which I wanted to say in India cricket is also played, then in India football is also played, and in India there is also chess which is played, right? So if I try to convert your dictionary into your pandas series object, it will give me the last value because it has overwritten all the values, because it will take only the last value, right? So this we can solve it by giving the index, right? So here you can say that all these games are played by a single country and we are trying to give the index, right? Okay, so here in this example only I put a comma and then I could write I'll take another example, example 5 equal to pd dot series. Here I could say the names of the games played in India, that is cricket, then it is football, then it is chess, right? So here I will say index equal to India, comma India, comma India, right? Now you can see that we can get all the games which are played in India and the index is same, right? So this is how we can solve the problem if you are having multiple indexes and the indexes are same, that is duplicate, right? Okay, the next part is how we can convert our numpy array to the series object. So that is pretty much easy, right? First we create a numpy array, right? And then we convert this in a similar fashion which we have converted earlier, that is pd.series, and put this array into conversion of a series object. So similarly in this case also we have converted a numpy array into a series object, right? So here I will take series 6, right? So first of all I need to create an array. I will say numpy underscore array equal to np dot array, and in the array I will take 1 2 3 4 and 5, right? pd dot series and here I will say numpy underscore array. Now you can see that this numpy array has been converted into your series object. So this was conversion of your list into your series object, dictionary into your series object, and your numpy into your series object. Then we will do some kind of numpy operations, right, such as filtering with boolean values, arrays, scalar multiplication, or math functions will preserve the index value, right? So whatever you try to do with your series object, and if you try to multiply with some scalar value or with some other series object, right, so it will preserve the index value link first of all, right, and also it will give you the results. For example, in this object, this is a series object and we have multiplied by 2, so all the corresponding elements has been multiplied by 2 without changing your index. Here we have taken the exponent of this object, series object, and all the values has been exponentially taken, right, has given us the results, but the index is preserved, right. We also wanted to check whether this object and give me those values which are greater than 0. This is known as boolean masking. It will result in true or false, and if we try to subscript it, right, by using this notation, it will give us all the values which are greater than 0, right. Also we can also check if some particular key element is present in our series object or not, right, so it will result us in the true or false value, right. So this is some kind of operations we could do it in the case of a series object. So let us try to do this operation. For example, this is our series 6, and if I try to multiply it by 2, so it will give us all the values which are being multiplied by 2, right. Also if I try to check if series is greater than, give me all the values which are greater than 2, or you can see that 3. Okay, let's take 3, right. So it has given me a boolean value, that is true or false, right. And if I try to get the value, so I put this thing under a subscript and then try to run it, so it has given me all the values which are greater than 3, that is 4 and 5, right. So this is how your operations work in your series. Okay, the next thing is you need to count the uniqueness, right, or you need to find how many elements are unique in your series object. So that function is your unique, dot unique, right, and value counts. So value counts gives us that how many values of a particular entry is being repeated. For example, A is being repeated 2 times, B is being repeated 2 times, C 1, E is also 1, and D is also 1, right. So these are the two functions which we can operate on our series object, and we are trying to find the unique values as well as count of these unique values, right. So let us try to formulate a problem, and then we could have this thing. So we say try to create a series with the help of our list. So I'll say okay, right. So this is my, I have converted our, so this is my list, I have converted into our series object, right. So okay, so here in this part I have created a list, right. In this list, so there are some elements which are repeated. So you can see that 1 is repeated, 2 is repeated, 3 is also repeated, but the unique elements are only 1, 2 and 3, right? So if I wanted to find out what are the unique elements which are present in my series object, so I can check it by using my u.unique function, right? Similarly, if I wanted to check that what frequency of these elements occur, that I could check it by using my value counts. This say element 1 is present 5 times, element 2 is present 4 and 3 2 times, right, in this series object. So these are the two functions, that is unique and value counts, right? Okay. So one thing to note and to remember is that in your pandas, index object are only responsible for holding the axis labels and other metadata like the names or the axis names, right? So we have your index, right, and the index objects are immutable, so we cannot change the index, right? So we cannot have, for example, A, B, C index are fixed. We cannot modify the index that is present at the location 1 from B to D, right, because they are immutable, right? They can't be modified by the user. We can only reindex this, but we cannot replace it or we cannot change it. We only need to reindex this part. I can reorder this part, but I cannot change by giving a assignment operator and say that change the value of the index residing at position 1 to D, because it was B and now change it to D. So that I cannot do, right? So let us try to see this. Okay, so I'll take the index, okay, I'll take the series 2, right? So series 2 I have 1, 2, 3, 4, 5. So if I say the index, so these are my index, right? So let's say I try to say what is at my index position 0, so it has 1. So if I wanted to change it to, let's say I'll change it to capital 1, so it has given me the error. Index does not suppose mutable operations. So this says you cannot change your index, right? Okay. So then if we encounter some kind of problem, so how to face this or how to overcome this situation, right? So here in the example you can see that there is a series object with the index as D, B, A and C, right? So I wanted to change my index or reindex according to my correct position, that is A, B, C, D and E, and you can see that E is not present, right? So only index up to D is present, but here I wanted to reindex to another index, that is E also, which is not present. So if it is not present, it will give us the NaN value, because the value corresponding to this E index is not present, and it will by default give you the NaN, right? And if I want this position to be filled by some kind of a constant value, then I need to give this value to fill value equal to 0. I can give any value, I can give it to 1, 2, 3, likewise any value, right? So then it will change to 0. So let's try to see this. Here, so we have our series dot reindex, right? So we have already created our index. Now I would try to reindex this. So let's see. So we have our series 2. So let us try to print this, and these are having the index. So I just want to change it to some ABCD, right? So let's do this, or I wanted to reindex this. So I will change it to reindex. So I just want to have 2 first, then I wanted to have 4, then I wanted to have 5, right, and 1 and 3, then 6, right? Okay, now you can see that, so it has been ordered correctly according to our index, that 2 comes first, then 4, 5, 1, 3 and 6. But here 6 we were not having initially any value, so it has given us the NaN value. But if I wanted to have some value or fill some value, I can change it by giving it a fill value 0, so it will result in 0. If I will give it to, like, let's say 6, so now 6 is present at the index 6, right? So this is how we can reindex our series object, right? Okay, now we'll cover the other part, that is data frame, right? So far what we have covered the how we can have our list, Python list, converted into our series object, then we have our dictionary, then we have our numpy array, then we have also seen the reindexing, right, and also seen that the index of our series object is immutable, we cannot change it. Okay, now what is data frame? So data frame represents a tabular spreadsheet like data structure containing the ordered collection of items which can be of different values, right? For example, in this simple layman terms, we could think it of as a dictionary of series which are sharing the common index, right? 2 or more series combined to form a one tabular spreadsheet like data structure which consists of a same index. So here you have a state, right, which is in the form of our dictionary, right, and we have the year also, which is also in the form of our dictionary. They are having the key value pairs, right? All this will share our single index, that is 0 to 4, right? We can also change this index by specifying the index also, but they will share the same index, right? So this we have to keep in mind, how many entries we are trying, all the entries would be same, right? In the state 5 entries are there, in the year also there are 5 entries, in the population also there are 5 entries. So, and the command or the class is pd.dataframe, right? So this is also a kind of an object which we are trying to make it, right, and have the different series combined into a one data frame, right? So let's first try to make up the data, right? For example, I have some names of some employees, right? So I'll take Sunil, Akash, Vipul, Mohit, okay. Then I'll take company, right? So it's working in IBM, working in Google, is working in Amazon, working in Flipkart, Microsoft, right? Then I'll take salary, so 50,000, 50,000, 70,000, 80,000 and 1,20,000, right? So this my data has been created. So this you can see that. So I have created some data which is in the form of key value pairs, right? So let us try to create a data frame. So in this data I put this data, and I'll say cell underscore data, right? So if I print this cell underscore data, all the arrays must be of same length. Okay, so it has given me the error. Okay, so now here the company is of 5, right? Name we have put it 4, so I just need to add another name, right? So Ram, so I'll add another name. It is Ram has been added. So now, okay, so now it is correct, right? So this problem will occur if the entries are not similar. So here in this case we have missed one name and it has resulted us in the error, right? If you will not specify the same entries in your all the columns, right, so it will not create you a data frame because the index is same, right? Okay, so this is how we could create our data frame by putting the data in pd.dataframe, and it will give you the structure in which we have the names, we have the companies, and we have the salaries of the employees, right? Okay. Okay, so if you pass a column that isn't contained in the data, it will appear with NA values in the result. For example, so here in the data frame we have passed the data and we have passed the columns, and there is the index also, right? And in the data we are not passing any entries to this depth, so it will result all the entries corresponding to NA, right? Here by default we could have cell underscore data dot columns, so it will give you all the columns. So these are the 3 columns, that is name, company and salary. If you wanted to try to access the index, so that can be also be indexed by using the index attribute, that the range starts from 0 to 5, right? Okay, so here we could have our columns and here we could have our index also. Okay. For example, if I wanted to create a new column in this data frame, that could be done by using the assignment operator. For example, here I wanted to create a new column, that is text, and I wanted to give the text as 0.2, right, to every employee, because based on the structure, so they have having 20% text. So that has been created. Now you can see that a new column text has been added and all the values of the text is 0.2, right, that is 20%, right? Okay, so we could also name our index and columns by using their attributes. For example, we could have frame name dot index dot name and frame name dot column dot name equal to state, right? So that we can do this part, right? Okay, now here the reindexing works in this similar fashion which we have already seen in the our series data series object, right? Here also if we wanted to have our data frame, and in this data frame we could wanted to reindex, right? So this reindexing could be done by using the reindex method and specifying the correct position of the index. Then that way we could have it, right? In this example you can see that the index was ABC, so we have converted to C, A, B and E, right? So in this A is not present, so E is not present, so it will give you NaN value. But if you wanted to have your fill value, so all these values will be filled with 0, right? So this is how we could also do the reindexing part in your data frame, right? Similarly, we could also have the arithmetic operations, right? So we have two series, right? Series 1 and series 2. If we wanted to have our arithmetic operations between S1 and S2, so we could combine these values, right? We could have the arithmetic operation between your series, right? Also, similarly, we could have all the arithmetic operations in our data frame also, in which all the values has been added into your corresponding data frames, right? We have the data frame df1 and another part df2. If we add this part, so all these corresponding values will be added, right? For example, 0 is 0 equal to 0, right? 3 plus 3 is equal to 6 and 6 plus 6 is equal to 12, right? We don't have any d, right? Here it has specified NaN because in the data frame 1 there is no index corresponding to d, right? So it has resulted in NaN. But if you want that the original d is present, then you can specify the fill value equal to 0, right? So this means if the other element does not have any index, so it will by default take the index which is present, right? So this is how you can do the operations on your data frames, right? Okay. So okay guys, so we'll stop here, right? So in the next part of this module, so we will cover the various functions of your pandas and your data cleaning part, right? And then we will also be looking on how to read your Excel from your Excel data from and convert it into your pandas data frame, and then apply various transformations into your data, right? So stay tuned for the next lecture. So hope you enjoyed the lecture. So thank you everybody.